Okay, next we move on to the medial tektites. Medial tektites are things like Philippinites, Bilitinites, Malaysianites, northern Indonesian tektites. These are all from the Australasian impact. Other ones, other medial tektites, is only the bediacites, which come from the Chesapeake crater, the North American strewn field. Now, the bediacites are roughly, I think, about 1,900, 2,000 kilometers from the impact site. The medial tektites we're looking at here are predominantly from the Philippines, and these are, say, about 1,300, 1,600 kilometers from the probable impact site. So let's have a look at some of these specimens. The medial tektites can actually be very interesting, and they fill in a gap between the splash form Indochinites, if you like, and the typical ablated specimens which you get in Australia. They fill in a very important gap, and I believe that tektites can be divided into basically 3 categories, or 4 if you want to include the layer type. But you've got the proximal Indochinite type, you've got the medial Philippinite type, and you've got the distal Australites. Now, I'll run through that a little bit more later. Okay, so here we are looking at some Philippinites. I hope it doesn't get too hot in here. I turned my air conditioning off because you might be able to hear a background noise there. That was probably the air conditioning. It's up there. So here are more space pictures. I like collecting them. I hope it inspires my son. Probably not. Okay, here are some very typical larger Philippinites. Let's have a quick look at these. These are burger type. These hamburgers, you call them hamburgers because they've had this, they're kind of bifurcated. They've got this ridge always runs through. These are simply cores. They're large cores. So this is the posterior, the original primary surface. This is the anterior, which is spooled. So the specimen came in like that, and it's spooled. Now, one of the interesting things about Philippinites is they come from spherical shape to a flattened ellipsoidal shape. They never go to discoidal. You never get a biconcave or concavo-convex disc as you do in Indochina. They've just not been flattened that much. They've not had that much atmospheric interaction. And again, we go back to that centrifugal argument. If it's centrifugal forces, then where are the discs in the medial setting? They just don't occur. They're less flattened because they've had less atmospheric interaction. If you look at the bubble pressures, they've formed at higher altitudes. You've got a mixture. Some of the Philippinites, they're pretty much unique in that they've had very little atmospheric interaction, and in fact have re-entered over the Philippines effectively as spheres. So they must have formed basically in space. Why is this? It's because the medial tektites get into space quickest. The proximal tektites, now these are travelling at lower velocity, but probably at a higher angle, so they're going to get into space more directly, but the slower velocity means they don't quite make it. We look at Australites, they're travelling at very high velocity, but they're being ejected at a very low angle, perhaps 20 degrees might be a realistic angle. So it's taking them, they're travelling fast, but they've got to travel through a lot of atmosphere before they get into space. And then we come to the medial tektites. Now they're at a lower velocity. They probably re-entered about 4 kilometers a second or thereabouts. And but these are in the middle range, so they were ejected at a reasonably high velocity and a reasonably direct route into space. We're perhaps talking about 30 to 45 degrees angle of ejection, so it made it into space the quickest, and consequently some specimens, as they were forming tektites from the jetted material, they're effectively forming tektites in space, and therefore they were not flattened. So it's kind of a unique circumstance. We'll have a look in a minute, but the vast majority of Philippinites were flattened to a degree. So typically, if you look at an Australian Tektite, you take the posterior and you say, okay, that was originally a sphere. That's not true. We'll get to that in a minute, but Philippinites is very obviously not the case. So here is a typical core. Been weathered. These U-grooves are not primary. They are originally paper thin cracks, and over time glass effectively dissolves. The acidic water attacks the alkaline network in the glass, and it makes these grooves larger. Now if we put that specimen there, right, you could say, okay, this is the posterior, the groove side, that's the anterior. The groove side is spooled, so it's travelling like that. You can measure the sphericity of the posterior surface. This did not come from a sphere, it came from a flattened ellipsoidal body. Okay, here is another Tektite. This is from a different locality. You can see it doesn't have the deep U-grooves. This is very fresh. This is close to what it would look like when it fell. Very, very fresh looking. So these are spooled surfaces. Here is a nice one. Here's the posterior. Here's the anterior. The U-grooves haven't well developed. They're paper thin cracks. So it was travelling like that. These Tektites, so the vast majority were slightly flattened during atmospheric exit, and then spooled during re-entry to create a core. Now, like I said, some of these specimens, they actually went into space, and they were forming effectively in space, and they formed a sphere. Now when you get a sphere, you get what is a bread crust Tektite. So here we have a typical bread crust Tektite. I've got quite a lot of them. My wife thinks I don't need this many. She might be right, but it's nice to have a lot of examples. So this is a bread crust. It's like a football. You've got these cracks all over. These cracks have been formed during re-entry. Basically during re-entry the Tektite cools in space, and then as it re-enters it's heated up. Not sufficiently to ablate it in this case, but it heats the body up. It's then rapidly cooled, and as it's rapidly cooled, this is likely when the cracks actually form. Now in this case none of the pieces have spooled off. In other cases you get some spallation, and you get what I call a late stage orientation. But this would have originally formed from basically a spherical body, and the specimens which are around this size, say 150, 200 grams, they're always like this. They're always got a lot of cracks all over. They thoroughly cooled in space before they re-entered, maybe 7 minutes or so later, travelling about 4 kilometers a second as they re-entered. So these differ from the hamburger type that I showed you earlier. Let's have a look in here, because I've got some hamburgers in here. Not edible, unfortunately. Let's have a look at this one. Okay, so this is a hamburger. You can see it's got that bifurcated look. This is an oriented specimen. Compared with this one, this is unoriented. So this was a sphere. This was an ellipsoidal shape when it re-entered. Okay, so here are some Philippinites. Let's see if that stays up. These are some of the largest in the world. This, I can't remember which is which now. This is one of the largest true splash form Tektites in the world. It actually contains a large bubble, which is why it exists. If it didn't contain a large bubble, it would have fragmented. That's a plane, by the way. I live right by the airport, so we hear everything. This is slightly heavier actually, so perhaps this is the heaviest one, although not the largest by volume. Again, it contains a large bubble inside. This one here, I think it's over a kilo. It doesn't contain very much of a bubble inside, so it weighs actually a similar amount. Now notice how none of these specimens have that bread crusting U-grooves all over the specimens. I'll explain that now. Okay, so why don't these large Philippinite spheres, and they probably also occur over in Malaysia, the Malay Peninsula. There is one example in the British Museum which is similar morphologically, but not a lot coming from there. There should be a bit more coming from there. I think people just need to get in. I don't think they're as common as Philippinites, maybe because there isn't a large deposit with rays going across there, but there should be a bit more Tektites coming out there, and there has been some in the past. Right, here are the smooth spheres. So why do we not get U-grooving like on this? This was also a sphere when it re-entered, but it's a lot smaller. Now the reason why is because a body this size would have had sufficient time to cool in space, and it's probably only talking about 7, 8, 9 minutes, something like that, but it cooled sufficiently in space that when it re-entered it was heated up again on the exterior, and then it was cooled rapidly in the upper atmosphere and cracked paper thin cracks, which were then subsequently enhanced by glass corrosion. These ones, they didn't get U-grooves. They never had them. Now some people believe that they actually did develop this bread crust appearance on the outside and then have been thoroughly spooled to create a smooth core. Now this is not the case. There's not one single example where we've actually found a large sphere with a little bit of the shell attached. These shells don't work, and what people sometimes think are large shell fragments, they're actually just large bits which used to contain large bubbles which have fragmented. I think some of these larger specimens, they contained a lot of bubbles, and the very largest Philippine Tektites, which probably weighed in the order of kilograms, quite a few kilograms possibly, they're all fragmented. They never stay intact. So these ones, basically, because of their volume and a lower surface area compared to their volume, they retain sufficient heat that by the time they were re-entering the atmosphere, they were still red hot. So although they were also heated during re-entry, the whole of the body was still hot on the interior, and then when the exterior was cooling, the interior is still hot, it's still warming the whole body. So you don't get these cracks developing, and it's simply because the interior was still molten, or red hot at least, during re-entry. So there's a transition from these perfectly smooth large spheres to what I call a grooved sphere. I'm not sure if I got any good examples here. Maybe here I've got something which is perhaps a bit intermediate. So this is a bit intermediate, this one here. You've got some U-grooves. I would actually call this one a bifurcated core, a hamburger, but it's getting somewhere. You got less grooves here. It's moving towards this larger body, so it's pretty transitional, and then once you get to 400 or 500 grams, it's almost wholly smooth. By the time you're 600, 700, 800 grams, you've basically got a very smooth round specimen, because that was sufficiently molten during re-entry. Here are some more nice examples. This is a nice, very nice hamburger there. You almost want to eat it, actually. See why they're called hamburgers when you get one like that. Very nice specimen. This is a funny one. You got a crack going through there. It's quite heavy. I think that's over a kilo. That's the only reason it's there. Okay, so before we move on, I just want to introduce another type of Philippinite. It really probably belongs at the end of the story, because it is simply terrestrial modification. But as we're looking at Philippinites, let's look at it now. Andesite Philippinites. Fairly unique. You also get andesite sculpture on australites. You get it on Indochinites. You can see it on pedicites. Moldavite sculpture is basically the same as andesite sculpture. It's a V grooving. Let's look here. This specimen is actually from Bickle and not the classic Ander area. It's difficult to show you. Unfortunately, that's a fresh surface. Very nice thing. Let's find this one here. This is typical. It's very difficult to get a decent focus on this, but I'm sure many of you Tektite enthusiasts will be familiar with Ander sculpture anyway. It varies from coarse to fine. Generally quite an expensive thing, simply because the Tektites are relatively sparse. Here's a dumbbell, but it's very, very beautiful sculpture when you see it, and it's radiating. It goes towards the center of the body, or on bubbles. Bubbles often show Ander type sculpture. This is believed to be because some of these bubbles would have probably been caused by water vapor originally, so you got a little bit of devitrification on the bubble, therefore it's liable to attack. You've got tension. It follows lines of weakness, but this unique kind of sculpture, it's not representing a different type of Tektite. Morphologically they're basically the same. Morphologically that's the same as any other Philippinite. It's a medial Tektite. It's simply there's a nice one, if I can get it in focus. Very difficult to get a different thing. Morphologically, you see you've got the U groove superimposed. Morphologically they're the same as all the other Philippine Tektites. It's simply the geological environment that these specimens have been in. So with a glass you can attack the alkaline components in the glass, and this is normally the case because rainwater is slightly acidic, mixed in with some vegetation and that in the groundwater. The water is very typically slightly acidic, so normally you get this U grooving. This is any U grooving or pitting. This is typically associated with acidic waters attacking the glass, and it removes the alkaline components of the glass. In reality, I'm sure it's a lot more complicated than that, but this is just a generalization. Now, with the rarer andesite sculpture, what I think is happening is you've got a much more alkaline environment. I think they're being found on limestones, and the water is naturally more alkaline, and because of this, in fact, well, I know where Ander's coming from. The water is alkaline. If you ever try and take a shower there, it's fairly unpleasant because the water is quite briny and alkaline there. But the area is on top of limestones, so you basically, in the alkaline environment, obviously it's not attacking the alkaline components of the glass, the sodium oxides and such like. It's actually attacking the silica network. So when it's attacking the silica network, you get this V grooving which works its way inside, and it creates a very, very different sculpture. Now in reality it's obviously a lot more complicated than that. A lot of things are going on, and the sculpture itself is determined by the entire geological history, and it's likely been transported and been in different water environments, different regimes, different permeabilities, different porosities. It may have been transported, lost its sculpture, being resculptured. So the whole process is very complicated, but if we're going to do a very broad summary, this andesite sculpture is simply a reflection of probably more alkaline waters in general that have terrestrially modified the specimen. Okay, here are some more medial Tektites. These are Billetinites. Now they very much overlap with Philippine Tektites. Some of them look almost identical. I mean, some of these you'd struggle to, if you've written with a load of Philippinites, you'd struggle to differentiate. But generally Billetinites are a bit more like this. They have a lot more U grooving, so this is a very large one. Very happy with this one, cost me a fortune though. And you get these very fine bits, you get these nice little projections here. Very nice. Bellitonites are relatively rare. They come from the tin mines on Belitung. So that's what you see. These are from Java. These belong in the next category with the Australites. Unfortunately, these are not brilliant examples, but I'm probably struggling to focus. These are cores. We'll include them with the Australites next. The Bellitonites here, they're basically the same as Philippinites morphologically. It's a little bit difference in distance from the impact site. It's a slight variation, but morphologically they're medial tektites. They're exactly the same as Philippinites. So there are some Philippinites. There's plenty of Philippinites in this household, probably well in excess of a ton. Many of these boxes actually contain Philippinites. What we got in here? Well, they're actually Indochinites. Many of them, they're full of Philippinites. These are shell fragments. But when I say shell fragments, these are fragmented small specimens. Some of the larger specimens, like let's say this, this is actually a bubble here. It's not really a true shell fragment, it's a fragmented bubble rich specimen. Right, so that's the medial tektites done.